All right, hello everyone. This is going to be the screencast video for problem number 6. Here we have a population proportion, and again we're going to use a hypothesis test. Just wanted to make reference to the PowerPoint slides that you can get out of Loud Cloud. I'll also put them up in the announcements. So basically we're just going to look at this. We're going to use a Z test, and we're going to do the Z statistic is computed this way. This is the formula for the computation of the test statistic. Everything else will work exactly the same way as the other kinds of hypothesis tests, and I think that we are going to be using a two-tailed test to see if the proportion is different in this case. So let's jump back over to our problem. We have 46%, so that's the pi, that's the population proportion. That's what the report claims the population proportion is. But over here we have a survey, so here's our N, 120 college interns, and 51 out of those 120 is going to be the P, that's the observed proportion. And then we're going to eventually use a 5% alpha, and then we're going to find the p-value eventually. So once again, I've just kind of pre-populated a few things into Excel. Here's our pi, the 0.46, the observed proportion. I can just compute it right here in Excel. I can say equals 51 out of 120. And it'll compute the decimal for me. The N is the 120, that's our sample size. And the alpha value is going to be 0.05. Okay, so the Excel sheet's ready to go. The null hypothesis is always the equals side of this equation. It's not saying that the proportion is greater than or less than 0.46. It just says different from 0.46. So that's how I know that this is a two-tailed test and a not equals for the alternative hypothesis. Right, now we're going to go on and find the Z statistic using this formula off of the slide, P minus pi divided by the standard error term. I think that I'll compute the standard error term first, and then I'll put those pieces together to find the Z statistic. So let's find the standard error term, and that's going to be equal to, so I want to do the square root of pi times 1 minus pi divided by n. So SQRT for square root. Pi times, I should have probably put the 1 minus pi, but I'll just build it into the formula here, 1 minus pi. Okay, so pi times 1 minus pi divided by n, and then close parentheses for the square root. So there's the standard error term, and now the Z statistic is going to be equal to P minus pi. So P is here. Let's put the parentheses, P minus pi, and then divide by the standard error term. Okay, so our Z statistic is negative 0.76928. And let's see if we got it right. 2 decimal places, negative 0.77. Negative 0.77 to 2 decimal places. Okay, now we're going to convert this Z statistic into a p-value. Instead of finding the critical value, we're just going to convert this right away into a probability. So our p-value is going to be taking this Z statistic and then finding the two-tailed probability that it's outside of that. So I'm going to find the percent of the population that's to the left of that, and then I'm going to double it. So 2 times, because I'm doubling it, it's a two-tailed. And then we're using the Z distribution, so norm dot dist. And we'll accumulate the probability. Oh, I forgot the equal sign. Equals 2 times norm dot dist. We'll use the Z statistic with a mean of 0, standard deviation of 1, because it's the standardized normal distribution, and accumulate true. Okay, so our p-value is 0.44, 0.44. They want 3 decimal places this time, 0.442. And finally, we can reach a conclusion. So the p-value is not lower than our alpha value of 0.05. 0.05 is much lower than 0.442. So there is not sufficient evidence to determine that the proportion that had unpaid internships is different from 0.46 because the p-value is in this case greater than the level of significance. And I think that's the end of problem 6. Hope you all have this has been useful, and I wish you all the best. Please let me know if you have any questions or I can be of any assistance.